Okay, we're going to talk a little bit about the Pythagorean theorem. Now, that has a strange name. Theorems in math are things that can be proven. That means that this rule that we're going to be using is something that can be proven. And if you'd like to see a proof, all you have to do is search on the internet, and there's several of them out there. This first word, Pythagorean, actually comes from the name of a Greek mathematician, Pythagoras. He is given the credit for this particular theorem, although probably he just helped write it up and teach others how to use it. So Pythagorean's theorem has to do with right triangles. A right triangle is a triangle where one of the angles is a right angle. A right angle equals 90 degrees. And it looks like the corner of a box. Oh, that doesn't look very good. Let's try that again. So if I follow this box here, that creates a right angle, which is why we often put a little square in it so you can tell which one of these angles I mean to be the right angle. So a triangle can have only one right angle, and so if you're doing Pythagorean theorem, there needs to be a right angle in the triangle that you're working with. Now, there are certain words that we use to describe the sides of a right triangle. The sides that make up the right angle are called legs. So this makes up one of the sides of the right angle. This side makes up the other leg. Notice those two legs are two different lengths, so sometimes you'll see those subscripted, leg sub 1 and leg sub 2, because there are two legs and they're different. This long side that is opposite the right angle is called the hypotenuse. And what the Pythagorean theorem tells us is that if you take the leg 1, leg sub 1, and you square that number, and you add that to the square of leg sub 2, you will get the square of the hypotenuse. And this will always work, that if you take the square of one of the legs plus the square of the other leg, it will always equal the square of the hypotenuse. Builders often use that to make sure that the corner of a house or a room happens to be a square or a right angle. So let's take a look at how we're going to use that in math. I'm going to put that rule up here one more time. There's my picture of a right triangle, sort of. And Pythagorean's theorem. Now let's take a look at an example with numbers and how we might use that. There's my right angle. Let's suppose this side is 3 inches long, and this side is 4 inches long. then the formula says that 3 inches squared plus 4 inches squared will be equal to whatever this side, so we'll call it x, is an unknown, is squared. Notice I'm going to square both the 3 and the 4. So x squared is equal to this. Well, let's see what this is. This is 9 square inches. This is 16 square inches. And 9 plus 16 is 25 square inches. And we've learned that we can solve something like this by saying that x is equal to the square root of this side. And in fact, if it's squared, there were 2 possible answers. Now, as important as those 2 answers are when we're doing math, when I'm solving for a triangle, the negative answer would not make any sense. So I'm actually going to erase that negative sign. Well, the square root of 25 is 5. And the square root of square inches is inches. So this side is 5 inches long. These numbers are easy enough that if you wanted to verify this, you could actually draw something with your ruler and check to see if that does give you a right triangle. All right, I want to try a little bit harder problem. I'm going to put my little rule up here in the corner again. That's my right angle. So that's not a very good right triangle, and I want you to only know to use this with right triangles. So I'm going to take the time to redraw that. Make that a nice right angle. And again, my rule is that leg 1 squared plus leg 2 squared is equal to the hypotenuse squared. So let's suppose that we know that this side is 12 centimeters. And this side over here is 15 centimeters. And my side over here that I don't know is this side, so we'll call this x. So the formula says that leg 1 squared plus leg 2 squared equals the hypotenuse squared. Notice that one of the legs is 12 centimeters. And the other leg is x, because the legs make up the right angle. And that those two added together equal the hypotenuse squared. So now I want to solve this equation. Just in case we're not certain what this is, 12 squared is 144. And 15 squared is 225. For those of you going on to Math 65, you should be trying to copy the units as well as the numbers as we work through these problems. Now to solve for x squared, we want to subtract 144 from both sides. 144 square centimeters. So x squared would be 225 centimeters squared minus 144 centimeters squared. You can see how what we were doing earlier with squares and solving equations is really important here. The difference is 81. X squared equals 81 centimeters squared. That means that x is the square root of that. Again, we learned it should be the plus or minus square root, but when we're working with geometry, only the positive answer makes sense. Square root of 81 is 9. The square root of centimeters squared is centimeters. So our answer for this side is that it's 9 centimeters. And we got a couple of examples where the answers came out exact. There were no ugly decimals. It turns out that when we're working with real triangles, very often we're going to get some answers that have decimals that we have to round off. So let's do one more problem where that's the fact. Just in case we're not certain, because I'm not, this angle up here is the one that should be the 90-degree angle. And we're going to make this side equal to 6.1 meters, and this side equal to 7.2 meters. We want to calculate this side over here. Let's call it y this time. Right, according to Pythagorean theorem, we have that the leg squared, one of the legs squared, plus the other leg squared is equal to the hypotenuse squared. Sometimes I just shorten that to HYP. Easier to spell. So let's put that into our formula. The legs make up the right angle, so we have 6.1 meters squared. Get my units in there. Plus 7.2 meters squared. If you're putting your units into your equation, make sure that you are also using parentheses, because you know that if we only put 7.2 meters squared without the parentheses, we're not squaring the numbers as well, we're just squaring the units. And that should equal the hypotenuse. Now the hypotenuse is opposite the right angle, so this is the hypotenuse. So y goes on the other side of the equation. And now I want to solve this equation. So I've got 6.1 squared plus 7.2 squared. Let's do a little work over here. And I did all of that arithmetic over here in one step. The result is 89.05 meters. Since I don't know what y is yet, I don't want to round that number off. To solve for y now, we know that we need to take the square root of this side. And this is a number that we'll want to round off. Now there's two ways you can think about rounding this. We could, since we're doing some multiplying with squares and square roots, use the significant digit rule. But I actually like to use the perimeter rule instead. And the reason for that is, if you think about it, we've got two sides of a triangle and we're looking to find the third side. We're really working with the outside of the circle there, or the outside of the triangle there. And since all the other measurements were measured to the 10th, of a meter, it would make sense that this y side should also be rounded to a 1/10 of a meter. It's our perimeter rule that uses place value, and I think in this particular example it makes a lot of sense to use that rule. So rounding this off to the 10th place, this would be 9.4 meters. And again, I'm ignoring the fact that there really should be plus or minus, because when we measure a side of a triangle, we would never measure it as a negative side. Okay, you will be doing some practice on the next presentation using Pythagorean theorem. If you need to, you might want to open the book to page 228 so that you have the formula in front of you when you're working. If you're uncertain and not ready to start your examples yet, you can work through example 5 on page 229 and read through that before trying